So I just hit start stream or
Yes, it's we're live. So hey guys, my name is Jan from DoraHacks and happy to have you guys here today. And today we have the second workshop of the Akash Hackathon, and we have Anil Murty here, and he will share more about Beyond Limits, Akash Networks, AI New Frontier explored. You guys have any questions in the meanwhile, drop them in the comment section and we can do some Q&A at the end. If you have not subscribed to our YouTube or Binance Live channel, feel free to do that now, because there's more workshops and also demo sessions and a closing ceremony. So whenever you're ready, feel free to start.
awesome. Thank you, Jan. Hey everyone. As Jan said, my name is Anil and I'm with Overclock Labs. And today I want to kind of talk a little bit about a few things. What I thought would make sense is do a little bit of content for people that are not familiar with Akash as much or are just starting to explore Akash, and then spend most of the time talking about things that people are more that are familiar with Akash can do as part of this hackathon. So to start off, I thought I'd start a little bit with a little bit of history on in terms of why Overclock Labs and Akash decided to pursue GPUs as the next big thing that we focus on from a product strategy perspective, and then what's sort of been the driving force behind it, and where we see that going in the future, and why it fits with our original mission. So I'll do a little bit of background on that, and then I'll talk about a quick overview of how Akash works under the hood for people that are not familiar with it. And then I'll jump into a quick demo showcasing some of the AI related things that you can do with Akash, with GPUs and Akash, and then talk about some of the tools that you can explore, open source tools as well as Akash specific tools that you can explore when you start to think about your projects as part of the various tracks that are in the hackathons. So that's kind of the general plan. There'll be some deviations here and there, but hopefully we can stick to that agenda. So okay, so to start with, just a quick background on Akash. So essentially, Akash started out as obviously this marketplace for cloud compute, a two-sided marketplace for cloud compute, where everybody that has excess cloud capacity or excess cloud resources or excess server capacity can bring that onto Akash and monetize it and offer it for a lower cost to people that need that compute capacity. So the whole thesis behind Akash from the beginning was that there is enough compute capacity in the world sitting in various data centers around the world that is not being utilized or is being underutilized. And if there was a way to make it easy for developers to be able to access all that compute capacity, then that would be a win-win for both sides of the equation, because now the data centers can take all their unused capacity that they've already spent money on and monetize it. And then the developers get a cohesive, unified experience for deploying on any of these data centers, similar to what they can do with public clouds, right? So that was the general idea. So Akash got started on this way well back in the day, well before the AI revolution, way well before the decentralized physical infrastructure networks or DeepIn wave came about, which came about probably in the last 1 year. But one of the things we realized very early on was, at some point there's going to be an inflection point where, GPUs are going to really accelerate in terms of their usage among various people that do infrastructure or utilize infrastructure. But what we didn't anticipate happening is how much the demand for GPUs is going to break the existing cloud model. And so, what do I mean when I say that the demand for GPUs has broken the existing public cloud model? So, here's essentially what I mean. Basically, what has happened in the last 1 or 2 years, if you think about it, is every single application that's out there, regardless of whether it's a consumer application or an enterprise application, they have all evolved or are trying to evolve to become an AI app. So, regardless of whether you're using Google Sheets or Google Docs today, or you're using, any of your consumer apps that you use today, they have some sort of AI element built into them, and that's only going to keep accelerating more and more going forward. So obviously, all of this has resulted in every single company out there, regardless of what type of application it's building, has resulted in them needing accelerated compute. And accelerated compute, as you know, is the idea of being able to take tasks that are extremely parallelizable and making them run as fast as possible. So this is something that CPUs are not really good at doing, but GPUs are really good at doing. And so this has really driven the demand for GPUs very, very high in the last couple of years. And that has totally changed, the trajectory of what we're seeing in terms of growth. So all this demand for accelerated compute has basically completely tipped this equation between the demand and the supply for these GPUs. And what that has resulted in, I think, is a couple of things. One, obviously, is because the demand is far outstripping the amount of supply out there, the prices of these GPUs have gone really high. But the bigger problem is that even if you're willing to pay these really high prices for example, the NVIDIA H100s or the NVIDIA A100s, in many cases, if you go to these public clouds, you have to actually commit to a year or 3 years of paying for these GPUs before you get access to them. So what that means is that if you're a tiny startup today, you have to essentially spend a huge amount of money up front in committing to these GPUs for 1 to 3 years or something of that sort, right? So if you think about it, the whole idea with the cloud back in the day, back in 2005, 2006, 2010, was that you should be able to reduce the barrier to entry for a startup that wants to build something by not having them having to commit a huge amount of capital expenditure by building their own data center or standing up their own servers, and let them use compute on demand. But this whole GPU supply demand dynamic has broken that promise, right? And so now, if you're a startup, if you want to get access to the latest and greatest GPUs, you have to pay the cloud companies a year or 2 years or 3 years of money. And that's basically like standing up your own data center in some ways in terms of cost. So that's what I mean by the promise of the quote unquote traditional cloud being broken by the supply and demand dynamic. So the question is like, how does Akash essentially address this? So basically, the same approach that we have had from the get-go since the founding of Akash applies perfectly to GPUs as well. The idea now is that similar to what we did with regular compute, with accelerated compute and with GPUs, we can take all this GPU capacity sitting in various parts of the world and bring it onto this common marketplace where we provide a cohesive software layer between all the infrastructure and all the users, and let all the users access a common interface that looks the same in terms of deployments, regardless of which servers you're deploying on, whether they're owned by entity one or owned by entity two or owned by somebody else, right? What is interesting though is that the GPU market dynamics have actually accelerated the need for something like this. And the reason I say that is because let's say you're a company, you're a mid-size or a big-size company today, and you've committed a huge amount of money to one of the big cloud providers in order to get access to, let's say, H100s a year ago, or maybe soon GH200 GPUs from NVIDIA. Now you have all this capacity that is sitting around, and in many cases, it's not doing anything for you. Meaning you might be doing some sort of AI training workloads, but these AI training workloads are not something that run throughout the year. Maybe you train a model for a couple of months, and then you take that model and you run inference on your application. You see what sort of feedback you get, and then you go back and fine tune or retrain that model for some time, right? So maybe you end up using your entire cluster or your entire cluster of GPUs for about half or less than half of the time through the entire year. Now, what do you do with all that capacity while it's not being utilized? It's basically a sunk cost to all these companies. And so our good old model of taking excess compute capacity in data centers now applies really well to that scenario as well, where the people that have committed to public cloud resources could potentially bring those resources when they're not being utilized onto Akash and offer them up to people that aren't able to get access to them as well. So that's a general idea, applies very well for GPUs as well. So to talk a little more under the hood about, or before we get into that, one of the things you've noticed probably in the last, if you've been in the crypto space particularly, is you probably noticed that there's been a whole bunch of projects that quote unquote claim to be a decentralized marketplace similar to Akash, and claim to be decentralized deepins, so to speak, right? Some of these have a product that probably works. Some of them don't even have a product. They're just basically talking about having such a marketplace. But one thing that differentiates Akash from all of these other places is, or a couple of things that differentiates us from all of these other places is, number one, we are the only company out there that is completely open source. What I mean by that is not only are we built on open source, the best open source tools and technologies, or the project that's built on the best open source tools and technologies, but we're also the only decentralized project or decentralized protocol today that is completely open source in terms of how we build our product. So on the left here, you can see, you can go to github/akash-network, and you'll see that literally everything that makes Akash run today, whether it's the core protocol, the nodes, the validator code, the provider software, the CLI, the console, all of that software is open source. So literally anybody can contribute potentially to this code base. But then we take that one step further and we say, not only are we open source, but we also have an open development model. So what that means is that nearly every single thing or every decision or every sort of thing that gets built on Akash gets built in the open. And the way we do this is through something called a SIG and work group model. And this is something that we borrowed from the Kubernetes project, which is this open source orchestration tool. And so the idea here is that these special interest groups, they focus on various sort of vertically aligned areas of the project or the protocol. So for example, we have a special interest group dedicated to providers, and these are people that meet regularly and talk about everything provider related and work on improving the lives of providers on the network and how we can sort of make them successful. Similarly, we have a group dedicated to clients. We have a special interest group dedicated to community, to economics, so on and so forth. And then we have got these work groups, which are sort of horizontal cutting across these special interest groups, and they are focused on driving forward a specific initiative. So for example, when we were working on GPUs, we had a bunch of work that happened across providers as well as clients. And so this GPU work group would involve both of those folks and make sure that when we launch GPUs, it all works together really well. That's basically how we operate in an open development model. And I don't know of any other crypto or non-crypto project today that is running a distributed or decentralized infrastructure platform that does an open source, open development model. So switching gears and talking a little bit under the hood, because this is at the end of the day a hackathon, and I want to get a little bit in the weeds for people that are not familiar with Akash. This is the typical workflow of what it looks like for deploying applications on Akash. So you start on the left and you work your way towards the right here on the slide. So you as a user, meaning you're somebody who wants to run a given application or a given workload on the Akash Network Supercloud, what you do is you take your application, which typically has to be a containerized app image, so it has to be a Docker container, and then you write something called an SDL file. The SDL file stands for Stack Definition Language, and put simply, what it is basically a place where you define what your infrastructure stack should look like in order to run that specific application. So you're basically telling the network, hey, this is my application, and this is what I think it needs in terms of CPU, memory, storage, etc., in order to run itself. So you take that, you write the SDL file, and then you submit it onto the network. And then what happens is that the Akash software that's running on each and every single one of the providers on the network, it receives this request, and it looks at it, and it's able to review and say, hey, can I honor this request or can I not honor this request? And if it can honor the request, then it responds back with something called a bid. And this bid is basically saying, hey, I can run your workload. Here is a little bit of information about me as a provider. And here is how much it's going to cost you if you chose me in order to run your workload. So you get back all of these bids, which look like, essentially like a reverse auction. It's like, provider A, provider B, provider C, so on and so forth. This is a price. And then you pick a provider and you say, okay, I'm good to go. I want to go ahead and deploy onto this. And then, within a few minutes or a few seconds, in some cases, your app is running on that provider and you have an entry point into that. And all of this, all of the bidding process, as well as the what we call essentially a lease, all of this happens on a blockchain. And the reason it happens on a blockchain is because we can allow this to happen between any two parties that decide that they want to work together and make this happen programmatically in some sort of a smart contract-like way, where no human interaction is needed. And so that's where we really leverage the power of a blockchain to make this work. Awesome. So I talked about SDL, the stack definition language file. So quick run through on what a stack definition language file or SDL file looks like. Um, for those people that are familiar with infrastructure or have done Docker and Kubernetes in the past, this should look very, very familiar. But essentially, this is very much like a Docker Compose file, and it sort of has 4 or 5 sections to it. The first one up top is what is the app or service that you want to run, and basically you specify the name of the service, the container image that you want to be running, and what ports you want to be exposing from within that container so that anybody can access your application if you chose to allow them, whether it's an internal service or it's an external user trying to access your service. The next is what we call the compute or resource profiles. This is where you define what resources are needed for the application to run. So this would be the number of CPUs, the number of GPUs, amount of memory, amount of storage, so on and so forth. The next one below that is where would you like to run this, and this is typically indicated in terms of attributes signed by specific providers, or specific providers with signed attributes, which kind of dictates which providers you can or cannot receive bids from. Below that is how much are you willing to pay in order to run this, and then last is how many replicas of this do you want, which is indicated by the count out there. So very similar, very simple structure. For those that are familiar with Docker Compose, it should be completely familiar. But we also have a UI-based deployment tool that sort of makes this really easy to deploy as well. So in order to showcase that, what I thought would be nice to do is to also point you towards a couple of interesting tools that you may or may not have heard of. So as you're thinking about the tracks, one of the tracks out there is obviously building some sort of an AI inference or training application. So a couple of tools that are interesting for this is one of them is called Olama, and you can access it right here at olama.com. So if you go to this is basically a repository for APIs to various models, so container images as well as then a running API built into that. So if you go ahead and click on the models here, you can see that they have all the common open source LLMs, and this is specifically focused on LLMs, but a whole bunch of LLMs. Each of these has basically the container image available to you, as well as the parameters that you can pass to the API when you call it. And then the other tool that I want to point to is sort of not LLM but image generation based. And so there is this tool called Confi UI, an open source tool developed that is basically a way for you to create a stable diffusion pipeline, a custom stable diffusion pipeline. So diffusion models, as you know, are used to generate images from text, and arguably the most popular diffusion model out there is Stable Diffusion. And the Stable Diffusion team at Stability AI itself uses Confi UI for testing new releases of Stable Diffusion. So this basically lets you start from a checkpoint and then add various stages to the diffusion process and then produce an image at the end. So these are really cool open source tools that you can leverage for specifically for inference on the LLM side as well as on the image generation side. If you're looking at training, I can point you to a tool called an open source tool called Ray, which is really useful for building training clusters across multiple servers. So in Akash's case, as you know, we have a whole bunch of providers on the network. So Ray is really useful because it lets you essentially do distributed machine learning across multiple servers. And so if you're curious, there's a blog post that goes into how you can run Ray clusters on Akash, and there's an example of running an STL and all of that as well. So definitely take a look at that if you're interested in going one step further beyond inference and looking at training as well. Okay, so with that, I'm going to jump into some quick demos here and show you quickly how you can run, for example, Olama and get an inference API that you can then query and run inference with. So I watched Scott's video from a couple of weeks ago, and I noticed that he already did a pretty extensive demo of console, so I won't go into super detail here. This is the provider page where you can look at all the providers on Akash network. Each of these dots represents a single provider on the network. Each of these providers can have anywhere from 1 server to 10,000 servers under them. And you can look at all the providers that are up there in terms of resources as well as individual providers out here. Now, if you want to deploy an application, you can go ahead and click on the deploy button here. And here what you'll see is there's basically two ways that you can go about doing this. If you're just exploring, you can click on search marketplace. And here what we have is we have a whole bunch of ready-made templates for applications that you can deploy. And there's a good categorization of them in terms of AI apps, databases, so on and so forth. But what you can also do is if you have something custom, a custom SDL that you want to deploy, you can go ahead and deploy that using the build template option. So here what you can do is you can either use the UI here to indicate your Docker image, the name of the service, the type of the GPU, so on and so forth. Or you can do what I'm going to do, which is you can go ahead and click on the YAML portion of this, clear out all the YAML here, and then copy your SDL. So what I'm going to do now is I'm going to copy an SDL that I have for deploying Llama. So here is that SDL. And as we saw in the slide, what we have here is you're saying we want to run this Olama image, which again is coming from this Olama website, or basically from the folks that maintain Olama. We want to expose these ports, and we want to pass some command line arguments to it. So a specific command line argument that we want to pass is this one, which is basically going to, once the container is spun up, it's going to run Olama serve and then pull down a specific AI model. In this case, it's Mistral, but you can replace this with one of these models out here, and then it's going to go ahead and run that, right? So let's go ahead and try to do this. So we're going to click on create deployment, and what happens now is that Akash basically asks you to create something called an escrow account, which is think of this as this is a two-sided transaction where on the one side there is the provider that's going to be running your workload, and on the other side is you that wants to run your workload. And so there has to be some way for you to be able to pay them for it, right? Now, one way to go about doing that is to say, hey, we're going to charge you entirely for, let's say, a month or something. And then if you at any point close your thing, we'll return that back to you. What we do is we basically create something called an escrow account between you as the user and the provider that's going to be running it. And we say, okay, deposit a certain amount of money into this account, and then the provider withdraws or is allowed to withdraw a small portion of that as time goes on. And then at any point, if you decide that you don't want to be running this workload anymore, or you don't want to be using the resources on the provider anymore, if you close that deployment or close that lease, then you get the remaining balance on that back to your wallet. So to be able to create these transactions, what you need is a Kepler wallet. So Kepler is the wallet, most commonly used wallet for the Cosmos ecosystem. And Akash is obviously a blockchain that runs on top of Cosmos. It's an app chain that runs on top of Cosmos. So go ahead and get the Kepler wallet, install it as a browser plugin. And then once you do that, load up some AKT in there, and then you'll be able to run this. So it'll default to 0.5 AKT, which is the minimum you require, but you can change this to anything you like. What happens then is it basically pops up a confirmation saying, hey, do you want to sign this transaction and broadcast it? Now, what's happening at this point is that we're taking your requirements in terms of those SDL file, and we're broadcasting it to the entire provider network on Akash. So what has happened now is that that transaction has been sent on the network, and every single provider that's sitting on the network is looking at the requirements that you sent over in terms of that SDL file, and it's saying, hey, can I run this specific, can I honor this resource requirements, and can I run this workload or not? So what I've gotten back now is I've gotten back a whole bunch of bits, and what I requested in that was 1 GPU, 2 CPUs, 17 gigabytes of memory, and 53 gigabytes of storage. And so you can see I've got bids all the way from $76 to $1,500. And $76, you've got an RTX 3080, all of these different types of NVIDIA GPUs, T4s, 3090s, 4090s, all the way up to H100s. So for this specific example, I'm just going to go ahead and pick an RTX 4090, which, by the way, we've seen a huge amount of people use these for inference, and they seem to have a really good price to performance ratio when it comes to running inference apps. So I'm going to go ahead and pick that one. Now there's going to be another transaction, and what's going to happen now is that a lease is going to get created between you meaning your wallet, and this provider being its provider's wallet. And so once that lease is created, that lease is recorded on the blockchain, and now your application gets deployed onto this provider. And so the way the deployment on the provider happens is that every single Akash provider runs a Kubernetes cluster, and that Kubernetes cluster then goes ahead and pulls down the container image that's specified in that SDL file. So here we said we want to deploy Olama. So it's going ahead and pulling down that specific Olama container from Docker Hub. It's creating a pod, and then it's scaling up that pod to the amount of replicas that I specified in that SDL file. You can jump into the logs here, and then what you'll see in the logs is, because we specified that we want to pull down a specific AI image, in this case Mistral, the logs are going to show you that the container is basically pulling down that image. So you can see that it's working. It's about 56% of the way there. Once this is complete, what you're going to see is that if you go into the leases place here, it says that this is deployed now because the container image is deployed. If I go ahead and click on this, you can see that it says Olama is running. So the base Olama image is running on this provider now. But we got to wait until it pulls down the actual AI model onto the containers or onto the provider as well. And so once that is complete, then we'll actually be able to go ahead and run inference with this as well. So to show the example of running inference on this, what I would need to do is actually share my entire screen. So I'm going to stop screen share and share screen. Okay, so now that this is completely deployed, it says success down here. What I can do now is I can go here, I can click on these ports, and you can notice that it says this is the provider, and that's the port that is exposed, 32062. So what I can do now is I can basically run a command from my command prompt that passes a prompt to this model. So the Mistral model that's running here, here you can see on this side. I'll increase the size of my command line window. So what we have here is now we have the Mistral AI model running here, and I'm going to go ahead and replace the port number because this port number is different now, 062, which is that thing right there. And what I'm going to do is I'm going to basically call the API/generate endpoint, and I'm going to pass it the model parameter of Mistral. And I'm going to say, what is Akash network? And let's see if this works. So what's happening now is basically I'm querying the...
Maybe zoom into your terminal. I think that would make it better for the audience that they can see it.
Increase the size?
Yes. Like also, I think if you press Command+, it might get bigger.
Yep. How's that?
I think it's still very hard to see.
Okay, let me do this. Let me go ahead and just share the command line. That might be easier.
And I think you can press like Command+ in order to like zoom in and increase the font.
Yep, I did that a few times, but it's obviously not big enough. Is it coming up now?
Not yet.
Okay. Let's try this again.
In the meanwhile, if the audience have some questions, feel free to just drop them in the comment section.
Okay. How's that?
Now it's a lot better.
Amazing. So yeah, so what I did here was again issued a curl command with that provider port and provider host name, followed by /API/generate, which comes from the documentation in Olama. And then I passed it the name of the model, and I passed it a prompt. And then what it's done is it returned back to me basically the response to that. So it says Akash Network is a decentralized cloud computing platform built on Ethereum blockchain, blah, 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 all this. So obviously then you would write an application that would parse all this information and display it back if you were building a chatbot or something. So that's the general idea here. So just a quick demo of how that looks like. So go ahead and go back to, go back to presenting my other screen. Awesome. So that's a quick deployment example. A similar example you can try is for Confi UI. So to try Confi UI, which is basically that Stable Diffusion pipeline that I showed you before. It's even easier than this. What you just do is go to deploy here, go into search marketplace, click just search for Confi UI. And if you just type Confi, you can see that there's a Confi UI template readily available here. Go ahead and click on deploy here, and then you'll find again an STL file pre-populated. Here we're loading a Confi UI image. We're passing it a bunch of environment variables that are needed by the container in order to go and configure Confi UI correctly. And then again, resources, we're asking for 6 CPUs, 1 GPU. We don't care which type of GPU it is. I'm going to keep that open so we get a bunch of bits. And we just want to be running one replica of this. So go ahead and create deployment again. And so what we should get back now is a bunch of bits again, this time for these resources. The number of bits we get might be different from what we got before because this resource requirements are different from what we had for the Olama example. But we'll wait for that to come back. And then what you'll see is that the process of deploying this is exactly the same as the other one. So here again, we've got a whole bunch of bits. I'm going to go ahead and pick this really expensive one just for trying it out. Again, there's going to be a lease created between me now and this new provider. And once that happens, then it's going to go ahead and try to deploy this image onto it as well. The reason I picked this was not just for showing the example of image generation, but also to show you that you can actually get into the command line once the application is deployed and do a bunch of things there as well. So here again, it has pulled down the container image and brought up the pods, scaled it up to the replicas that are specified. Go and look at the logs. It says starting Confi UI. And then what I can do now is I can click on this lease thing. I can see again that there's an endpoint here. If I go ahead and click on the endpoint now, it'll actually show you that Confi UI is running. So you can see that it took me barely like 2 minutes to get all of this up and running, get Confi UI up and running. So now this is this exact same thing that I showed you that in this GitHub repo, where you can specify all the stages inside of the diffusion model and go ahead and create an image. So in order to create an image with Confi UI, one of the things you need to do is you need to load a checkpoint because by default, Confi UI doesn't come preloaded with any checkpoints. So the way we can do that is by accessing the shell or the command line directly on that container image. So to do that, go ahead and click on the shell. And if you do an ls here now, you can see the various folders here. One of the folders here is Confi UI. So I'm going to go ahead and go into Confi UI. And once I go into there, and remember now I'm actually running all of this directly on the provider itself. So I'm actually SSH into the container instance that is running on that provider. So they've got a bunch of folders here for Confi UI, but I'm going to go ahead and go into the models folder. And inside here is where you can put your embeddings, your upscalers, your checkpoints, so on and so forth. So what I'm going to do is go into the checkpoints folder now. And there's no checkpoints there. It says put checkpoints here. So what I'm going to do is I'm actually going to do a wget of a checkpoint that I found online. So that's the checkpoint. It comes from Hugging Face Stability AI's space inside Hugging Space, and it's basically a checkpoint for Stable Diffusion 1.0. Go ahead and do a wget on that. And so what's happening now is it's basically the container image running inside that provider is doing a pull of this image from Hugging Face's repository. Hugging Face, for those that are not familiar, is like GitHub but for AI models. It basically has the biggest repository of open source AI models out there, including data sets and various other things, documentation and such. So definitely something to check out. So okay, so now that this is complete and it has downloaded the image, we can go ahead and now go back to this thing. I'll just refresh this so it actually loads back with that checkpoint. And so now you can see here that it's loaded my SDXL base 1.0 safe tensors checkpoint, which is the one that I had copied over from here. So now what I'm going to do is I'm going to go ahead and just click on Q prompt. And the default prompt here is a beautiful scenery. It says nature, glass bottle, something. What it's going to do is it's going to show you a green box as all of this progresses. and then ultimately it's going to produce an image here. So let's see what that looks like. And so there's the image. Now I'm going to go ahead and replace this just to do a test of a different image generation. So I'm going to go ahead and replace it, try to generate like a living room, modern living room, Scandinavian style, blah, blah, blah. Again, Q prompt here. And this time it's going to be a lot faster because it's already loaded the checkpoint. So you can see now it's produced this image. So really easy to do image generation as well, using open source tools on an open source cloud. So that's all the demos that I wanted to show you. With that, I'll kind of wrap things up by talking a little bit about our roadmap for the Akash console that I was using to demo this. And the reason I want to talk a little bit about this is because some of the tracks that we put out there, outside of the AI track, there's also a couple of other tracks which talk about building dashboards and talk about building potentially fiat payments for Akash network. I want to talk about our roadmap a little bit because it'll be nice if people build applications or ideas in this hackathon that contributed to this, if possible. So one of the key barriers to more adoption of Akash, as much as it's grown, there's a lot more we can do, is that there's a significant barrier to entry for people that are moving from traditional public clouds to Akash today. So if you're a developer that's using, let's say, AWS or GCP or Azure, or even like DigitalOcean or something else, and you're coming to Akash, there's some things that are going to look very alien to you. So what are those things? First off, the most obvious is that you need to have some amount of crypto familiarity. So you've got to have a wallet, and you've got to be able to know how to get AKT or USDC, one of those things, right? So that's a barrier, and that's something that we would like to overcome. And we have plans to build, features into console that'll offer a way for people to do pay using regular credit cards or some way of paying using regular good old money, US dollars. So that's problem number one. Second problem is if you're somebody that just wants to try this out before you commit to spending more time with it, there needs to be an easy way for being able to do a free trial, very similar to what you can do with public clouds today, where if you go to AWS and create a new account, you get probably $100 or something. Maybe they start doing it now. The third one in the list is basically this bid process. So if you're somebody who's coming from a traditional cloud platform, the bid process is very alien because you don't understand what that means. And so providing this option for people that don't understand the bid process and just want to deal with an instance type, being able to just pick an instance and deploy onto it is something that we're very interested in building. Notifications. So one of the things that you noticed about that deployment workflow was when you actually deploy something, it shows you how much time is left on that deployment, meaning that is how long it'll keep running with the amount of balance that you have in that escrow account. It would be really nice to be able to notify me or notify the user that they're running low on funds and their deployment is going to close. So notifications is a key area or a key problem to solve. Queryable events and logs. So we obviously have events and logs that show up in this UI here. But if I was looking at this several days later, maybe the deployment closed, there's no way for me to know what happened. If it's something that there's a container that crashed or ran out of memory, there's no way for me to know. So that's another area that we're very actively interested in solving from a problem standpoint. The next one here is SSH from command lines. So one of the things that people that come from other platforms that are not decentralized is they just like to be able to get an instance, drop their public SSH keys onto it, and then go ahead and do whatever they want from their command line. So while we have the concept of a lease shell today, what will be really cool is offering a way for people to be able to just get access to it from their own command line and do that very easily. And so there's kind of two approaches we think that we can take with that. First is to basically offer a bunch of what I call plain vanilla Linux images, similar to what you can find with public clouds. So maybe Ubuntu LTS 22, SUSE, some other Linux distro, and then take the user's public key, get it onto that, and then offer them a way to SSH into that. And then the other option, which actually a team outside of the core team is actually actively working on right now, you can look at it in the discussions on GitHub. So if you go to Akash Network and go into discussions here, there is an active discussion for essentially building a streamlined pipeline for deploying container images in an automated fashion. Lots of discussions out here if you want to check it out, but that's another way of achieving that objective, which is getting a link to the person's GitHub repository, which might be like a React application or something, and then taking care of building the Docker image and deploying it in Akash in an automated fashion. And then the last problem that I want to talk about here is once somebody has deployed their application and has gotten an endpoint, similar to what we got in the two examples that I showed today, that endpoint is typically a provider endpoint. So it's like provider hostname colon some sort of port number. What obviously people want to do is they want to be able to set up HTTPS with a TLS certificate and then create their own custom domain mapped to that. So making that process really easy is another area to look at. So that's about all I wanted to cover for the session today. Basically give you a quick overview of Akash for people that are not familiar with it, talk about why we built it, or why the core team built it and open sourced it. What is special about Akash relative to potentially other people that claim to be a decentralized marketplace? How do you get started if you're the first time you're using Akash, and how you can sort of work with console and understand how to deploy an application image? And then if all of this has you excited and wanting to build something as part of the hackathon, and you're looking for sort of inspiration around what might be useful, here are some good examples of things that you can consider building on. And I think that's about it. So with that, I'll hand things back to you, Jan.
Yeah, so thanks a lot for your presentation. It was super insightful. I believe the audience learned a lot about Akash. Maybe, first of all, we give the audience some time to ask questions, or like digest the info and then ask questions. So maybe you could elaborate a bit, like what would you like to see at a hackathon? You mentioned like a few different ideas just now, and maybe also like what's important when they build on top of Akash, like what should developers take into account?
Yeah, so I think there's a couple of things, right? So one is, what are the tools that are available to you to build? If you go into GitHub/Akash Network, and actually I'll just share my screen again and show what I'm talking about as well. So if you go into GitHub/Akash Network, obviously this is the place where you can find pretty much. Actually, I just realized I'm not sharing my entire window screen. So this is obviously the place where you can find our entire code base. CloudMos is the tool that I was presenting the deployment from. Node and provider are the code that runs on the provider side as well as on the various nodes. All of these things are available out here. One of the things that you might find interesting is if you are a JavaScript developer, there is a SDK specially designed to help you out if you're building on Akash. So this is a JavaScript library and has a whole bunch of examples of how you can programmatically create deployments, manage deployments, close deployments, etc. So if you go into the example here, there is a good example of how to programmatically create deployments using JavaScript or TypeScript. So this is a good example to look at for somebody that is, for example, building an application that wants to do deployments automatically. Maybe you're some sort of cloud aggregation idea where you're combining resources from AWS as well as from Akash, and you want to do deployments programmatically. This is a good example to use. There is also a general gRPC API that's available. So if you just go to if you search for API here, see Akash API, and this has all of our API documentation. So you can check this out as well and use that for building the things that you want to build. Yeah, so just a few different ways that you can interact with it. In terms of inspiration, I talked about some of the ideas out there, but I think generally what will be cool is if we have folks that hopefully most of the people that are participating in the hackathon are people that are engineers, either development engineers or infrastructure engineers or SREs or DevOps engineers. Um, More than likely, these folks have probably used AWS, Azure, GCP, one of these things. Think about what are the things you can do to make it easy for somebody like yourself that's coming from one of those places to Akash, to make that transition really seamless, and then try to build something that makes that possible.
Yeah, I think onboarding experience is very important.
Yep.
And also thanks a lot for the resources you just shared. In the comments section, there's like no comments. People are thanking for the nice workshop. If there's like anything left you would like to add or mention, feel free. And if not, we could like wrap it up very soon.
No, I think that's about it for my side. I'm just really excited to see the stuff that people build. I look at the DoraHacks page pretty regularly, like a few times a week, just to see if there's any people commenting about the projects that are building on. I also pop into the Discord channel for DoraHacks to see what sort of things people are building. And yeah, super excited to see what people come up with. And then if there's somebody that wants to potentially take it forward even beyond that, would love to work with you in terms of community discussions, proposals, and so on and so forth.
Yeah, likewise. I'm also very excited to see all the projects building at the Akashathon hackathon. And thanks a lot for your time for the presentation. I think it was very insightful. Our audience learned more about Beyond Limits, Akash Networks, AI, GPU Frontier Explored. And so like if the audience has any questions after this workshop, like they can watch it asynchronously, what's the best way to reach out to you?
Yeah, so the best way to reach out to me is I'm on Discord. So you just look for in the Discord, in Akash Discord, just look for Anil Core Team. My handle is Climb Pride Runner, but it shows up as Anil Core Team as the name. I'm also on Twitter. So Twitter handle is _Anil_Murty. Just look for that. And yeah, that's probably the two best ways to get in touch with me.
Yeah, all right. So thanks a lot and see you soon.
Thanks so much, Jan, and the DoraHacks team for hosting me. Right.
Thank you.